Tests for ions. They are to use hydrochloric acid to detect carbonates. Add dilute hydrochloric acid. A solution containing carbonate ions will fizz because the carbonate ions react with hydrogen ions in acid to give CO2, carbon dioxide. Cl3 2 minus aqueous plus 2H plus aqueous form CO2 gas plus H4 liquid. When water turns the solution cloudy, we know it contained carbonate ions. Test for halides. Add dilute nitric acid, add silver nitrate solution. Chloride gives a white precipitate of silver chloride. Bromide gives a green precipitate of silver bromide. Iodide gives a yellow precipitate of silver iodide. Using a pH indicator test for hydroxide, the OH minus ions make the solution alkaline, so we dip a piece of red litmus paper into solution. If hydroxide ions are present, paper turns blue. Test for sulfates with hydrochloric acid and barium chloride. Add a little dilute hydrochloric acid. Add barium chloride solution. If a white precipitate of barium sulfate is formed, the original compound contained a sulfate. Hydrochloric acid is added to remove any traces of carbonate ions before you do the test, because they will also produce precipitate, confusing the results. Using red litmus paper and sodium hydroxide test for ammonium ions. NH3 is alkaline. The test is done using a damp piece of red litmus paper. The litmus paper needs to be damp because so the ammonia can dissolve. So the ammonia can dissolve. If ammonia is present, paper turns blue. NH4 plus aqueous plus OH minus aqueous to form NH3 gas plus H4 liquid. Adding OH minus ions to a solution containing NH4 plus ions, ammonium ions react to form NH3 gas and H4 liquid. Add dilute sodium hydroxide solution to a substance in test tube. That we gently heat the mixture. If ammonia gas is given off, NH4 plus ions must be present. Using flame test to identify group 2 ions. Dip a nichrome wire loop in concentrated HCl. Then dip the wire loop into unknown compound. Hold the loop in clear blue part of Bunsen burner flame. Observe the color change of flame. If it's Ca2 plus ion, brick red flame color. SO2 plus ion, red color. Ba2 plus ion, pale green flame color. Using dilute sodium hydroxide solution to identify group 2 ions. Add sodium hydroxide dropwise to a test tube containing metal ion solution. Observe the precipitate that forms. Keep adding sodium hydroxide until in excess. Record any changes that you see. Mg2 plus with OH minus ions, slight white precipitate with excess OH minus ions, white precipitate. Ca2 plus with OH minus ions, slight white precipitate with excess OH minus ions, slight white precipitate. SO2 plus with OH minus ions, slight white precipitate with excess OH minus ions, slight white precipitate. Ba2 plus ions with OH minus ions, no change. With excess OH minus ions, no change. Say key fact about reducing something: halide ion needs to lose an electron from its outer shell. Reducing power of halides increases down the group as it's easier to lose electrons. Say 2 reasons attraction between nucleus and outer electron gets weaker. Because ions get bigger, electrons further away from positive nucleus, extra inner electron shells, so greater shielding effect down the group. Silver nitrate test for halide ions. F minus no precipitate, Cl minus white precipitate, Br minus green precipitate, I minus yellow precipitate, and that forms the slowest, forms the fastest. A precipitate formed of the silver halide. Adding ammonia solution, because each silver halide has a different solubility in ammonia. So this is just an extra step because each silver halide has a different solubility in ammonia. Chloride, white precipitate dissolves in dilute sodium hydroxide. Chloride, white precipitate dissolves in dilute ammonia aqueous, NH3 aqueous. Bromide, cream precipitate dissolves in concentrated NH3 aqueous. Iodide, yellow precipitate, insoluble in concentrated NH3 aqueous. Least soluble, most soluble. NaF solid plus H2SO4 liquid form NaHSO4 solid plus HF gases. NaCl solid plus H2SO4 liquid form NaHSO4 solid plus HCl gases. Mist diffuses as gas comes into contact with moisture and air, but HCl and HF are not strong enough reducing agents to reduce H2SO4. NaBr solid plus H2SO4 liquid with NaHSO4 solid plus HBr gases, then 2 HBr gases plus H2SO4 liquid form Br2 gases plus SO2 gases plus 2 H2O liquid. Mist diffuses of HBr. HBr is a stronger reducing agent than HCl, so it does reduce H2SO4, produces choking fumes of SO2 and orange fumes of Br2. NaI solid plus H2SO4 liquid from NaHSO4 solid plus HI gases, 2 HI gases plus HSO4 liquid from I2 solid plus SO2 gases plus 2 H2O liquid. Then 6 HI gases plus SO2 gases from 3I2 solid plus H2S gases plus 2 H2O liquid. HI reduces SO2 to HS. HS is a gas, toxic, and smells of bad eggs. Wet scrubbing, acidic. So from here, Mixing chlorine with water undergoes this proportionation reaction, and when it undergoes oxidation and reduction, the same element, so chlorine in this case, in sunlight, chlorine decomposes in water forming chloride ions and oxygen. Cl2 gases plus H2O liquid reversible reaction 2H plus aqueous plus Cl minus aqueous plus Cl minus aqueous. 2 Cl2 gases plus 2 H2O liquid are a reversible reaction 4H plus aqueous plus 4 Cl minus aqueous plus O2 gases. Say a key fact about group 2 elements, they lose 2 outer electrons forming 2 plus ions. They have a noble gas electronic structure. Why does reactivity increase down the group? First, ionization energy decreases, increased atomic radius / shielding effect. Group 2 elements react, losing the electrons, forming plus ions. Therefore easier to lose electrons, more reactive the element. Yeah, group 2 elements, they form 2 plus ions, have noble gas electronic structure. Chlorine persists in water and prevents reinfection further down the supply. Prevents the growth of algae, removing discoloration caused by organic compounds. Harmful if breathed in, irritating respiratory system. Water contains a variety of compounds from decomposition of plants. Chlorine reacts with these compounds, forming chlorinated hydrocarbons. Now, this is a bit extra for chlorine, but it could, I guess, in the exam ask you. Usually, it's just like state disadvantage of chlorine is toxic, respiratory problems, etc. You just need a state. It's always like a state question. I guess it could come up as maybe a 4 marker, evaluate chlorine, I'm not sure. But yeah, it's better to be safe than sorry, so learning these things about chlorine. But leave this to last, I guess. Yeah, leave this to last, because unlikely to come up, and if it does come up, chlorine, you can talk about a lot of things, harmful, kills microorganisms, but also toxic, and etc. Chlorine reacts with compounds forming chlorinated hydrocarbons. 2NaOH aqueous plus CO2 gases from NaClO aqueous bleach plus NaCl aqueous plus H2O liquid. Sodium chloride 1 solution bleach used in water treatment, used to bleach paper and textiles, good for cleaning toilets. Cl2 aqueous plus 2 Br minus aqueous to form 2Cl minus aqueous plus Br2 aqueous. Cl2 aqueous plus 2 Al minus aqueous to form 2Cl minus aqueous plus I2 aqueous. Br2 aqueous plus 2 Al minus aqueous to form 2 Br minus aqueous plus I2 aqueous. When halogens gain an electron, they become less reactive than the group as atoms become larger. Outer shell further from the nucleus, halogens become less oxidizing than the group as electrons are less strongly attracted to the nucleus. Halogen will displace a halide from solution if the halide is below in the periodic table. F2 pale yellow gas, Cl2 green gas, Br2 red brown liquid, I2 grey solid. State 2, so F2 pale yellow, Cl2 green, Br2 red brown, I2 grey. State 2 key facts about halogens down the group. The boiling point increases down the group, increasing strength of van der Waals forces, size and relative mass of molecules increases. That makes sense. But another thing is that the electronegativity decreases down the group. As larger atoms attract electrons less than smaller ones, as electrons further away from the nucleus, shielded by electrons. And that's what you need to say. That's a really key trend, because including myself, like, that's one I don't really recall. Electronegativity does decrease down the group for halogens, because larger atoms attract electrons less than smaller ones. Electrons further from nucleus shielded by electrons. Stable atomic radius increases down group 2. Extra electron shells are added to the group down as you go down the group. Pretty simple. Atomic radius increases as extra electron shells. Electronegativity increases up the group. Yes, it increases up the group, it decreases down the group. Why does first ionization energy decrease down group 2? Each element down group 2 has extra electron shell compared to one above. Extra inner shell shield the outer electron from attraction of the nucleus. Extra shell, therefore the outer electrons are further away from the nucleus, so greater shielding effect, reducing the nucleus attraction. Now that really is important. These first 2 points here, each element down group 2 has an extra electron shell compared to one above. Extra inner shell shield outer electron from attraction of the nucleus. But this third point, the idea that it is an extra shell. It's an extra shell. You got 1, 2, in this case, you got 3. It's an extra shell, so the outer electrons are further away from the nucleus, reducing nucleus attraction. Extra shell, outer electrons are further away from the nucleus, reducing the nucleus's attraction. Wet scrubbing is when acidic sulfur dioxide is removed from flue gases by reacting with an alkali. Wet scrubbing, acidic sulfur dioxide is removed from flue gases by reacting with an alkali, calcium oxide or calcium carbonate is used. Flue gases emitted from industrial exhausts and chimneys. gases emitted from industrial exhaust and chimneys. Slurry made by mixing calcium oxide or calcium carbonate with water, sprayed onto flue gases. Sulfur dioxide reacts with alkaline slurry, produces calcium sulfite, a solid waste product. CaO solid plus 2HO liquid plus SO2 gases form SO3 solid plus 2HO liquid. CaCO3 solid plus 2HO liquid plus SO2 gases form SO3 solid plus 2HO liquid plus CO2 gases. If acidic barium chloride added solution contains sulfate ions, and a white precipitate of barium sulfate is formed. Magnesium is used in the extraction of titanium. First things first, titanium oxide, TiO2, converted to TiCl4 by heating it with carbon in a stream of chlorine gas. Then TiCl4 is purified by fractional distillation before then being reduced by magnesium in a furnace at 100 degrees Celsius. 100 degrees Celsius. I think it should maybe say 1000 degrees Celsius. I guess it doesn't really matter. They're probably not going to ask you that, but now I'll double check right now, because I don't want to give you guys false information. Just checking now in the textbook, and it is 1000 degrees Celsius. That's why I did think as well. It is 1000 degrees Celsius. So never mind 100. It's TiCl4 purified by fractional distillation and reduced by magnesium in a furnace at 1000 degrees Celsius, not 100 degrees Celsius. TiCl4 gases plus 2 mg liquid form Ti solid plus 2 mg Cl2 liquid. Barium sulfate is insoluble. Barium sulfate is used in barium meals. Barium sulfate is opaque to X-rays. Therefore, it means it won't pass through it, helping diagnose problems with esophagus, stomach, intestines, wherever it may be. Because the X-rays, now the reason we use this barium sulfate using barium meal because opaque to X-rays and therefore won't pass through it, is because X-rays, they pass through soft tissues, right? That's why we need to use this. The patient swallows a barium meal, a suspension of barium sulfate, and then the barium sulfate coats the tissues, showing the structure of the organs, therefore showing up in X-rays. Calcium hydroxide, slaked lime, used in agriculture to neutralize acid soils. Magnesium hydroxide, used in indigestion tablets as an antacid, substance that neutralizing excess stomach acid. Magnesium hydroxide is sparingly soluble, aka very, very low solubility magnesium hydroxide. Compounds of group 2 elements containing singly charged negative ions increase in solubility down the group, whereas compounds containing doubly charged negative ions decrease in solubility down the group. M solid plus 2HO liquid form M solid plus 2HO liquid, M bracket OH squared, aqueous plus H2 gases, and this is what happens when group 2 elements react with water, oxides from 0 to plus 2. So just memorize this. Doesn't matter what group 2 element is, calcium, whatever it is, right? It's going to follow the same format. M solid plus 2HO liquid form M bracket OH squared, aqueous plus H2 gases. Group 2 elements react with water, therefore becoming oxides from 0 to plus 2. Water is the oxidizing agent. They react more readily down the group. Why? As the ionization energy decreases down the group 2. Why does melting point decrease down group 2? Now this one is also really, really important to know. Well, the metal ions get bigger down the group, so surely melting point would increase down group 2. No, because the metal ions get bigger down the group, but the number of delocalized electrons per atom does not change. Neither does the charge on the ion. Number of delocalized electrons on the atom per atom does not change. Neither does the charge on the ion. Larger ionic radius, further away the delocalized electrons are from the positive nuclei, therefore less attraction, so less energy needed to break the bonds. Now, you can see these last couple of days I've been posting a lot of year 1 content. Inshallah, if Allah wills, I will finish year 1 content by probably the end of this week maybe, and then I'll just move into year 2 content and then keep doing that, and then maybe get to a point, maybe in a couple of weeks time, I'm just doing one year 2 topic, 1 year 1 topic, etc. But yeah, I'm going to be posting more of these videos going through the content